Hello friends, today's question. A 4 kg block is tied at one end of the massless belt as shown. The belt, it should be belt not vest. The belt can slide on table. A 6 kg block is kept on the belt. The coefficient friction between the belt and the table is mu1 and 6 kg block and the belt is mu2 is same and is equal to 0.2. The system is released from rest. So we have to calculate three things. Find the acceleration of 4 kg, find the acceleration of 6 kg, and find the displacement of block with respect to belt on the table during the time the block reaches the pulley. So this is the basic diagram. Okay, let me redraw it again because it is not, you can say, clear how the belt and everything is connected. So let us draw. So this is the table. And on the table we have a belt and this is the belt. And this belt is connected to a block which is 4 kg, and on the belt there is a mass whose it is given as 6 kg, and this distance is given as 2 meters. Okay. So this is the belt and this is the table. And the belt is connected to this 4 kg block with the help of this pulley. So let us first of all find out all the frictional forces which will be acting between, and it is given that the coefficient of friction here it is given as mu1 and here it is given as mu2. So let us consider that for the belt and 6 kg, so let us assume that all the body means 6 kg, 4 kg and belt move with same acceleration A. Move with same acceleration given as A. So let us consider the 4 kg block. Say for 4 kg block, traveling in downward direction with acceleration A. So it is going to have, let us suppose, m4g and there will be tension T. So we can write the equation as m4g minus T will be equal to m4a. So it means 4a, and you can further write it as this will be 4 multiplied by 10 minus T will be equal to 4a, or we can say from here that T will be equal to 40 minus 4a. Let us call this equation number 1. Now let us consider the belt and 6 kg block and find out the direction of frictional forces. So both are moving. This is our 6 kg block and this is the belt, and both are moving in this direction with the acceleration a, and there will be tension T on the belt because of the friction between belt and the table. Let us suppose that is given as Fr1, and this belt will try to move 6 kg block towards left with a frictional force, let us call that as Fr2. So there will be equal or opposite Fr2 also on the belt. So these are the frictional forces which are acting on 6 kg belt as well as frictional forces. So let us consider for belt. So we can write the equation for the motion as, okay, and it is given that the belt is massless. Okay, so we can say as belt is given to be massless. The equation we get T minus Fr1 minus Fr2 will be equal to 0. Let us call this as equation number 2. And for 6 kg block, the 6 kg block moving this direction with the direction A, Fr2, okay, and you can say here Fr2 is equal to m6 multiplied by A. Or from here we can say Fr2 is equal to 6 multiplied by A. And let us find out what will the frictional force Fr1. You can say for frictional force Fr1. Now in case of Fr1, it is between the belt and the table. Belt, and here it is our Fr1, and above it we have a 6 kg block. So in the downward direction, as belt is massless, this will be our 6g, and let us suppose there is normal and belt. The coefficient of friction is given as mu1, that is 0.2. So we can say that our N belt is equal to 6g, and Fr1 will be equal to mu1 multiplied by N belt. So we substitute the value 0.2 multiplied by 6 multiplied by 10. So from here we get our Fr1 is equal to 12 Newton. So substituting this value in equation number 2, so we can write from equation 2 we get T minus 12 minus Fr2 will equal to 0. And from here we can say that T minus Fr2 will equal to 12. we already know that our FR2 is 6A, but FR2 is equal to 6A, so we can write this as tension minus 6A is equal to 12. So now we have two equations, equation number 1, and let us call this as equation number 3. So substituting the value of t from equation 1 to equation 3, sorry. So using equation 1 in equation 3, we get 40 minus 4a minus 6a is equal to 12. So we get this as 40 minus 12 is equal to 10a, and we get the value of acceleration is equal to 40 minus 12 divided by 10, and which gives us acceleration is equal to 2.8 meter per second square. So this is the common acceleration which we have assumed. Now let us find out what will be the value of friction for this value of acceleration. Okay, we already know the equation of FR2. We can say, but FR2 is equal to 6A. So from here we can say that our FR2 equal to 6 multiplied by 2.8. So we get FR2 is equal to 16.8 Newton. And let us find out the maximum value of the FR2, and we are going to make a comparison with this FR2. From here we can say FR2 max will be equal to mu2 multiplied by normal, and FR2 is the friction between 6 kg. So let us call this normal as N6. In the downward it will be 6g. So we have N6 is equal to 6g. So basically 60, and mu2 is given as 0.2. So this will be 0.2 multiplied by 60. So we get maximum value of the friction that is available is our 12 Newton. So maximum value of the friction is less than the friction of the which is being generated by the acceleration of 2.8. So from here we can say, but on comparing FR2 and FR2 max, FR2 max is less than FR2. So therefore from here we can say that the available value of the friction is less than the friction force which is being generated by the acceleration A. Therefore, the available value of maximum friction which is given by FR2 max is less than the value of friction that is being generated at acceleration is equal to 2.8 meter per second square. So from here it is clear that 6 kg block will not be traveling with the same acceleration at the belt. So from here we can say, thus 6 kg block will not be moving together with the belt. From here we can say that 6 kg is going to slip on the belt. 6 kg block slips on the belt, and the actual value of FR2, thus the actual value of FR2 will be equal to FR2 max, and that is equal to 12 Newton. So we found out what will be the value of the friction, and now obviously the 6 kg block will not be moving together with the belt. Okay, so from here also we can say that the acceleration of 6 kg block will be different, and let us suppose that is given as A. Therefore, the acceleration of belt and 6 kg block will be different. And let us assume that the 4 kg block will be different, and this will be also true for 4 kg block. So let us assume that the acceleration of 4 kg is given by some other variable. Let the acceleration of 4 kg block is equal to A4. So therefore we can write, therefore equation 1, we are going to get M4G minus T will be equal to M4 multiplied by A4. And we already know the equation of tension, that is from equation 2. From equation 2, tension is equal to FR1 plus FR2. We know the value of FR1 and FR2, so we substitute it. This is 12 plus 12, so tension T will be coming as 24 Newton. Now let us substitute this value into this equation and find out the acceleration A4. So M4 is, thus we get M4 is 4, G is 10, so this will be 40 minus 24, 4 multiplied by A4. So we get A4 is equal to 40 minus 24 divided by 4. So this we get that acceleration of mass 4 is 4 meter per second square. So this is the acceleration of the first part, 4 kg block. This is acceleration of 4 kg block. Okay, now we have to find out for 6 kg block. So let us write for 6 kg block, and we assume that its acceleration given as a6. So this is 6 kg block moving the acceleration a6, and it is fr2. So we can write that fr2 will be equal to m6 multiplied by a6. This will be 6 multiplied by a6, and fr2 is our 12. So here we can write that a6 will be equal to 12 divided by 6, or we can say that a6 will be equal to 2 meter per second square. So this is the acceleration of 6 kg block. Of 6 kg block. That was our second part. And for the third part, we have to find out the displacement of the block with respect to belt on the table during the time the block reaches the pulley. Okay, so the block reaches the pulley. Within that time, we have to find out what will be the displacement of that 6 kg block. Okay. So for this case, this is our belt, and this is a block of 6 kg, and the distance it is given is 2 meter. So from here we can clearly see, and the pulley is connected here. From here we can say that the belt has to move a distance of 2 meter towards left. You can say distance moved by the belt to the pulley is given as 2 meter. Okay, and the belt moved with the acceleration of a4, that is 4 meter per second square, which we already found out. So we can say acceleration of belt is equal to a4, and that is given as 4, and the block moved with the acceleration of block is a6, and which is given as 2. So relative acceleration of block with respect to belt. This is relative acceleration of block with respect to belt. So we can write this as a block with respect to belt is equal to acceleration of block minus acceleration of belt, and this is nothing but a6 minus a4. So we get A relative as you can see A relative is equal to 2 minus 4, so we get A relative as minus 2 meter per second square. So let us find out how much time does the belt take to travel the distance of 2 meter. You can say time taken by the belt to move 2 meter distance. Let us put that is given as t, and initially it is said they are released from rest, so initial velocity will be 0, so we can use s is equal to ut plus half So let me rephrase this again. We can say that so the time taken by the, you can say 6 kg block taken by the 6 kg block with respect to ground to cover 2 meters. Okay. And let that be given as t. So we can say that s is equal to ut plus half is 6 t square. So from here the distance is 2 meter, this is half, and a6 is over 2 multiplied by t square. So from here we can get that our t square will be equal to, this goes away and this is 2 seconds. Now we have to find out the relative with respect to the belt. Okay. So therefore relative distance covered by the block with respect to belt in time is equal to t. So we can use that s relative will be equal to ut plus half a relative t square. So from here we can find out that the s relative distance is equal to half a relative is given as minus 2 and our t square is 2 seconds. So 2 goes up with 2, so we get s relative is equal to minus 2 meters. So as we have considered that the motion of this entire thing is towards right side, but as the distance is coming as negative, so from here we can say that the 2 meter distance, you can say relative 2 meter distance will be toward right side. Okay. So this completes the question. Thank you.